Imagine person A wants to send a message to person B, but the only option is to use a messenger. The problem? The messenger could be malicious and might read the message along the way. So, how can person A ensure that the message remains a secret? The simplest solution would be for person A to put the message in a box and lock it, so the messenger can't open it. But here's the issue. If neither person A nor person B has the key to each other's locks, then person B won't be able to open it when it arrives. One potential solution is as follows. Person A locks the box with one of their locks and sends it to person B. When the messenger delivers it to person B adds their own lock to the box and sends it back. When person A receives it again, they remove the lock that they put on. Then, the box is sent back to person B, who can unlock the box with their own key and read the message inside. But there's a risk. The messenger could execute what's called a man-in-the-middle attack. When person A first locks the box, the messenger could sneakily add their own lock, pretending it's from person B. Then, the messenger would bring it to person A, who would unlock their own lock, not realizing that the box has been tampered with. The solution? Person B must have a way to prove that they are the intended recipient of the message, so the system cannot be tricked. Let's extend these principles to understand how computers can establish a secure connection over an insecure network. Say there's a person in a coffee shop who we will call the client. The client wants to talk to a website on the internet. However, another person in the coffee shop could be intercepting their connection. The way to do this securely is as follows. The client starts by sending a client hello to the server, initializing the SSL handshake. The server then responds with a server hello, including its digital certificate, which contains the server's public key. The client validates the certificate to make sure that the public key truly belongs to the intended server. The client uses the server's public key to encrypt a pre-master secret and sends it to the server. Only the server can decrypt this pre-master secret because it holds the private key that corresponds to the public key. The public key is used to encrypt the pre-master, and the private key is used to decrypt it. Now that both the client and the server have the pre-master secret, it is used to generate the session key, which can both encrypt and decrypt information. A secure connection has now been made over an insecure network, meaning that even if someone were listening to the setup of the encryption, they could not decrypt any future messages sent.